we're going to start. It's page 16 of your packet today, and it's a continuation of the chapter 19, part 3 notes. Yesterday we had talked about the finding of your sample size, but we did not go into the subtleties of this wording. It's kind of tricky, so we'll hit that today. Now, yesterday when we did our problems and our examples, we did problems 1 and 2, but I wanted to look at problem 3 with you because it is something worth knowing how to do. So I want you to read that problem number 3 for a minute and write down the information that it gives you. So do that right now. All right, so what information do we know from what's been given? We know sample size. Okay, good. What else do we know? Margin of error, good, is the 0.035. Okay, what else do we know? What proportion should we be talking about here? They didn't give us a p or a p hat, so we will use 0.5. Very good. Okay, so clue to you is if it ever references margin of error, you pretty much need the margin of error formula. So what is that margin of error formula? I put that there because I wanted to talk about it, but the margin of error formula, now, hey, if you're talking physically, if you're talking about a actual interval, what part of the interval is the margin of error? If you're talking an interval, what part of this interval is the margin of error? Good. One of the whiskers. Okay, good. So the whiskers are that margin of error. They are not the p hat. So I drew this right here because I wanted to show you that a common mistake that students make is they say margin of error equals, and then they put the whole formula. And I see this over and over every year on a particular free response on our test that we'll have at the end of this unit. And because it comes from an actual AP exam question, and that's a common mistake. Margin of error does not include that p hat. It only includes this whisker. So it's just that one little whisker that you got right there. Okay, so now fill in the numbers that you got and see what you solve for based on what you've been given. Okay, so I found the standard deviation to be 0.01719 or whatever. Okay, and so then I will take that 0.035, divide by that previous answer, and so my critical value, my z star, is that 2.03. So 036. So my critical value 2.036. Okay. So from that, I want you to just sketch a little normal model here, and on this normal model, put what this information means to you on that normal model. Okay, so there's that one, but what do we know about critical values? It's on both sides. There's the positive one and the negative one. So there really is, because that's when, technically, when you do this square rooting, there's really the positive and the negative one. So there's that. Now, the question asks, what degree of confidence is used for this poll? So my question is, looking at this normal model, label where you find the degree of confidence. Where on this thing would you find the degree of confidence? Where do you think? Yes. Remember when we put the degree of confidence, we put that here in the middle? So essentially, if you want to know what the degree of confidence is, you need to compute what this area is right here. Okay? So we need to compute that area from negative 2.036 to positive 0.2036. And how do you do that? Good. Norm CDF will give you that area from negative 2.036 to positive 2.036, and that is 0.9582. So guess what confidence level we have? We are 96% confident in our answer. Okay? All right. So hint, whenever they give you margin of error, they're pretty much giving you everything you need to know using this margin of error formula. So let that be your guide. All right, so let's now move on to the other part of today's lesson, and that is these subtleties in wording. I'm going to try and get those to make sense for you today. Okay, we already know how to interpret what a confidence interval is, because you write that every single time at the end of a panic model. So we're going to put that here in just a second, but the other thing we need to know is this, how to interpret confidence level. Okay, so let's do our interpretation of confidence interval first, and that's actually the second thing here. When you get an interval, what is that doing for us? What is that telling us? Beautiful. It's a range of numbers. Okay, that's a good start. It's a range of numbers. Good. And what does that range of numbers do for us? We're hoping it contains, we're so much percent confident it contains true proportions, but this range of numbers is actually, in a sense, what? Anybody? I'm kind of going, a range of values that are essentially a what? An estimate. Good job. That's the word I was going for. Estimate of the population value, population parameter, whether that be the population proportion. We'll also estimate a population mean. We'll do population differences. We'll do population slopes. Different things we'll estimate. Okay, so write down our typical confidence interval statement about our globe, the proportion of water on the toy globe. I'm going to use the numbers 52% to 68%. So fill in the rest of that on this confidence interval statement. I'm 95% confident that the true proportion of water on the toy globe is between 52% and 68%. Something along those lines. Okay, good stuff. Got that down. No problems there. Now, let's see how level is different. A confidence level, so they'll say interpret they'll say something like this: interpret a 95% confidence level in context of the problem. So what it is doing, for what a confidence level is doing, is it's interpreting how many of all the confidence intervals made of a particular confidence level. So I kind of just put that in a little parentheses there, and we'll talk about that in a second. How many of all the confidence intervals made of a particular confidence level? So this little statement here says you can't mix and match the confidence intervals. You can't have some 80% confidence intervals and some 99% confidence intervals and some 95%. So they're all 95% confidence intervals. So of all the 95% confidence intervals made, we're going to get an estimate of how many of those contain the population value that we're looking for. Okay, and after you write that, I'm going to show you what that means and the physical nature of what that really is talking about. How many of all those confidence intervals made? So this next page is a representation of that. So they're giving some other information, but I want to talk about, let's pretend that this is the proportion of, this is our water problem again. So, you know, everybody got all these different p hats, okay? And then they made their interval from their sample results, okay? So this was a whole bunch of intervals that people made, like we put over there on the board. Remember, over there on the board, we also had somebody who got a very weird sample, and that one was way low. Okay. But for our sake, most of the ones that we did kind of centered in that vicinity of the 55 to 65 or 70. All right. So what this means is we would say something like this: about 95% of all 95% confidence intervals contain the true proportion of blah, 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 whatever it's looking for. So they expect about 95% of all of the whole bunch of intervals. You know, I've been collecting them for 10 years. I've been doing that globe toss thing for 10 years. And so about 95% of all the ones I would make actually contain the true proportion of water that is on that globe. And okay, so this little applet, this is very interesting. So this, I'm gonna, if I say change this confidence level. So this currently is at a confidence level. Let's make the sample size bigger. Let's do a large enough sample size. Okay. And this is just various different things. Okay, let's do that. All right. So look at this picture. This is demonstrating the intervals, and then that vertical line down the middle, that's representing the true proportion of water on the globe, or whatever. And up at the top, it tells me the percent of intervals that contain that line that's there in the middle, that contain that true proportion. So watch this. I don't know if you can see this, but I have it currently set at 90% confidence. Well, at 90% confidence, look what that coverage is having. What percent of those intervals contain the true proportion of whatever it's talking about? 90%. So now I'm going to make some different size intervals. If I have a higher confidence, say 95% confidence, can you tell me what's going to happen to the size of my interval? Bigger or smaller? Higher confidence, bigger Z star, so bigger interval. Okay, so let's go up a little bit. Let me just, oh, here we go. That's good. Okay, so there's that. So it should be about 95% of the intervals contain the true answer. Here it has 92. It's not, foolproof. We could, I wonder what this does. Okay, so here let's go to 99%. Oh, look, 100% of the intervals contained it. Okay, there's 99%. Let's go down. Let's make smaller intervals. Let's go to 80% confidence level. So here I am about 80% confidence level. And how many of the intervals contain the true answer? This says 76%. It's not perfect. This isn't the infinity amount of intervals. But can you see that as I have bigger confidence, the intervals are a little bit wider. So if the intervals are a little wider, then more of them contain the true proportion of whatever the answer is. Okay? All right. Questions on that so you can visualize it? So, in summary, your statement that we want to have you write, a typical statement that you would write for confidence level would be something like this. You would say, let's do the proportion of water on the globe again. So we would say about 95% of all 95% confidence intervals about 95% of all of those intervals contain the true proportion of water on the toy globe. Okay, so just as you know a typical statement for the interval, you must also know a typical statement for level. In fact, I'm going to add that, and let's do that right now real quick. Add that to your homework assignment, which today will be only the the warm-up on page 26. So on page 26, real quick, the warm-up, I want to add a question because I should just make a note to do that in the future. The first problem is about the proportion of the professor's students who are registered to vote. And it's wanting a 95% confidence interval for that. So you'll do a panic model and get the interval. But I also want you to do this. Interpret 95% confidence level in context of this problem. Okay, so I'm adding that because you will be asked to make such a statement on the quiz as well. Okay, that's a needed thing for you to do. All right, so let's go on back to the notes on page 17. All right, and so down here at the bottom, there are some statements that are very tricky. I'm not gonna lie to you. When I went to a summer workshop and I did this for the first time, the teacher said, okay, I want you to list which of these is a true statement and which of these is not a true statement. And I was looking at them and I was like, okay, those all look good. They're all true. They all sound about the same. And like one of them was true. So I was like, okay, totally dumbfounded and shocked. And I have since kind of learned to tell the difference between them. it's so difficult. It's really subtle wording. So I struggle every year how to get you to understand. And I thought of maybe a way to do that this morning. So I made up this little story this morning while I was getting ready. And so it's new. If you want, I could make copies of this page and I'll have them ready if you want to get one of these tomorrow or something. But this is going to be kind of a weird story. But my earlier classes today have said that although it's kind of a weird story at first, by the time we go through all of the statements, it kind of starts making sense. So I thought, okay, that's good. And they seemed a little bit more successful on the questions. All right, so here we go. So this is a story, and I'm going to tell you that I have a tree in my backyard, and your job is to find its location by shooting a net gun in its direction and attempt to catch the tree. So, net gun, you know what I'm talking about when I say net gun? It's something like that. Okay, you're going to shoot that net out there. This guy's shooting at these obviously fake geese who would not let him get that close to them, much less shoot it that close to him. So anyway, it looked like they're swimming in the sand also. But okay, so there's our net gun. And you're going to try and find the tree. Sounds easy. I mean, how hard is it to shoot a tree? Well, it's a tree that is invisible. You don't know where it is. But you have to have some clue. You cannot just be randomly shooting anywhere in my backyard because it's a pretty big backyard. So here's another interesting fact. When the tree's leaves, so the trees are invisible, the leaves are invisible, but when they fall to the ground, then they get dirt on them, and then they are visible. So you have some clues. You have some hints. You can see the leaves. And so you have a general idea of where this tree is located. So you have those leaves are kind of hinting to you as to where you might want to shoot your net. All right. So everyone is going to use the same size net. It's called size 95 net, whatever that size goes into the gun. So everyone's going to use the same size net, size 95, so we have like the common denominator type idea. And this represents the net size that will give you 95% confidence that you actually captured the tree in your net. All right. So, weird story, but you kind of get the idea of what's going on. So, here's some statements that we can say. Everyone who casts that size 95 net can say that he or she is 95% confident that the size 95 net will capture the tree. Good? Follow that? What does that sound like, that statement? You're 95% confident that your size 95 net will capture the tree. Does that sound like, what kind of statement does that sound like? The confidence interval statement. Good. Okay. But we've got some issues, and this is actually not correct. I need to fix the idea behind this. Okay. So here is something, and this is why I came up, this is a difficult idea to understand, and so this is hence why we have the story. The tree is stationary, right? And cannot move. It is rooted in the ground. That tree is right there. It will not move. And you're shooting this net hoping to find it. So what happens is you cannot think of this terminology or this situation in terms of saying the probability or the chance that that tree will be in the net. And here's why. So that's always a no-no. Talking about the probability that that tree will be in the net, because that tree is stationary. If you say there's a 95% chance that the tree is in your net, then you've already shot that net. Let me say that again. If you say there's a 95% chance that the tree is in your net, you have shot that net. And so then that's saying 95% of the time that tree is going to move into your net, and the other 5% of the time that tree is not going to be in your net. And obviously that tree is set. It doesn't move. So you can never say or reference probability of the true answer being in that net. Okay, so that's kind of weird, but that's a definite thing we cannot reference when we interpret the interval. Also, here's also common things, incorrect interpretations. You cannot talk about other people's nets shooting and locating where my net is. You must keep in mind that the net you cast has no bearing whatsoever on the net that other people cast. So if the statement ever talks about other people's interval, other people's net being in your net or where your net's located, that's an automatic out. We have no care about that. For example, here's why. See this? What happens if this is my net? That's where I shot my net. The wind caught it and made it just like really suck in relationship way far away from the tree. Then I should not ever reference all these other nets landing where my net is. It's just not, that's not what the confidence is about, what intervals are about. Okay, so let's then go through some things that are false statements. These are definitely false statements. There's a 95% probability that the tree will be in my net. What's wrong with that statement? Probability. Okay, so very good. That's our automatic no can do. All right. We are 95% confident that all other nets will be found in my net. Okay, what's wrong with that statement? Yeah, it's not we, it's the fact it's referencing their net where? In my net. No, that's not what confidence intervals are about. What are confidence intervals about? Whether or not you do what? Capture the true proportion. Whether or not you capture the tree or not. It's not about whether you put your net lands where my net is. Okay, next. 95% of all people's nets will be located in the same area where my net falls. Okay, that's false. What's wrong with it? What? No, not all people's nets. Yes, it's the problem is I don't need no referencing where my net is. No referencing where my net is. Okay, here we go. Next. If many people cast their nets, about 95% of all of those nets, so you all cast your nets, will land in the same general area as my net. Again, it's talking about my net. No can do. You get the idea? Who cares about it landing where my net landed? Mine could be a freaky outlier. Okay, moving on. If many people cast their nets, about 95% of all nets will contain the tree. I like that. It's really close to being correct. So, because it is talking about 95% of all nets, that's where the problem is, contain the true location of the tree. This is a problem. Anybody want to know what actually is wrong with that? Yes. You know what kind of nets these are? Size 80 nets, size 90 nets, size 99 nets. This is a mixture of all the different kinds of nets there are. But this is saying it's supposed to be 95 right here. If many people, the second statement, if many people cast their nets, about 95% of all of the size 95 nets, see, we got to have that common denominator, contain the tree. Okay, so you see that slight difference? This is just any old willy-nilly net, the 80% ones, the 99% ones, all of them. That's bad. Okay. By the way, these true statements, I'm 95% confident that my size 95 net will contain the tree, and then we already talked about that one. So, in summary, let's just making sure we understand what's going on. What does the tree represent in this story in reference to our confidence intervals? The true proportion, good, that we are hoping to capture. What do the nets represent in my story? The confidence interval, the whole interval. See, it's wide. It's a net because that's the whole interval. Catching it includes the margin of error. Okay, very good. So now you get to come over here and read these statements and see what you think, but I will give you a hint. When it talks about this interval of 44% to 50.5%, that's my net. Okay, so you can keep that in mind that whenever it talks about that particular situation, that's my net. Okay, so I'll give you a few minutes to think through all of those and see what you think. We'll talk about it in a minute. Okay, here comes one more hint. When it says sample proportions, that's other people's p-hat. Okay, other people's sample results. Okay, so which I guess in turn you could make an interval from. It doesn't technically say that, but are other people's p-hats going to end up in my net? So that's what that's referencing. Okay, so you can think about that as well. So let's check these out. Let's check these out and see what you came up with. We're 95% confident the true proportion of voters in favor of Presidential Pete is between that interval I got, and that, of course, is true. B, 95% probability that the true proportion of voters is between 44 and 50.5%. What's wrong with that one? Yes, we talked about how that value isn't going to move into your interval. So that probability component is what makes that false. Okay, C. When it references, it's saying 95% of other people's p-hats. I guess, that's like saying, in a sense, if you made an interval from that, it's like saying everybody else's, where they shot or where they were aiming is in your interval. And that's not what intervals are about. So we are not about other people's nets being in my net. How about D? 95% of the sample proportions of voters for Presidential Pete will be between 44 and 50.5%. How is that different from the one in front of it? It's the same thing. Other people's nets in my net. That is not what intervals are about. All right. E. You know what? Actually, F is so similar. Look at F real quick. We are 95% confident that the sample proportion of voters, other people's p-hats, is contained in my net. What do you think about that? Again, same thing. So in my mind, F is almost says the same thing as D and C. But E is an interesting one to look at. E says, if this procedure was repeated many times, I like that. That's all of these intervals here. We had all of these intervals. It says approximately 95% of the resulting intervals would capture the true population proportion of voters in favor of Pete. I like that in the sense that it doesn't talk about it being in my net. Okay? It's actually talking about capturing the true proportion. But this is a teeny, tiny little thing wrong. So this one was the closest one to being a confidence level interpretation. What's bad about this saying the resulting intervals? 95% of resulting intervals. This referencing all kinds of intervals. All kinds or sizes of intervals. So that would mean your 80% confidence intervals, your 95% confidence intervals, your 99% confidence intervals. And what are we supposed to have when we reference a 95% of them containing the true proportion? What size do they need to be? 95% confidence intervals. So this could be corrected easily if it said 95% of the resulting 95% confidence intervals would capture the true proportion, and then it'd be correct. Okay, so while that tree story is a little strange at first, I hope that in the long run it kind of helped you understand what's going on. And so assignment-wise, I just want you to do page 26 as your warm-up, but I did want us to talk briefly about the first problem. So let's read that problem. A statistics professor asks her students whether or not they are registered to vote. In a sample of 50 of her students, randomly sampled from her 700 students, 35 said they were registered to vote. Complete the panic model to find a 95% confidence interval for the true proportion of the professor's students who were registered to vote. Okay. I don't like that right here, but I personally have a problem with that. Okay. So, first question, what is the sample size that we're going to be dealing with on this one? 50 or 700? The sample size is 50, so then my next question is, what is this? 700 students. Good. This is the population of all of her students. Why was it important for them to tell us that? Yeah, the independent rule. Independent in, ooh, why did I say 500 there? N is less than 10%. So I need 50 to be less than 10% of all of her students. And you know, I have 150 students. So would I be allowed to sample 50 of my students? No. So this is kind of unusual. I guess it's like, you know, a college, a university with lots of students in the classes. So they had to kind of wanted you to know that, so that when you make that assumption, it's a reasonable assumption that 50 is less than 10% of all her students. Okay, that's all that I wanted to go, and then you guys know you had written this question down as well. That's all.